Welcome to Reconstructing the World. Today we are at Terrace building, most sustainable architect in the world. Say hi.
Hi.
Anders Lendager. Today, what are we going to take a look at?
Today we are going to open our minds and hearts and embrace concrete. So we're going to talk about concrete today.
We're going to talk about concrete. We're going to mainly talk about how you use concrete for the most important thing of the building and how you always are thinking about bringing down the concrete. And just very recap for the audience out there. Why do we not like concrete, Anders?
We don't like concrete because it stands for 8% of the total CO2 emission globally. So it's a big sinner. It's using so much energy to create cement, and that's a huge problem.
That's one thing. The other thing is that to make concrete, we are draining the oceans for sand because it needs this rough sand instead of round sand. People always think, why don't you take sand for Sahara? And then we can't use that because it's too round. It's been rounded.
One of the other issues is also that the stone you use, the specific stones that you use for hard concrete, is something that is imported from Scotland or north of Norway and is not locally harvested. So there's many problems with that. But let's go in and see how far we can go. And I think you need to find a door.
No, part of the many problem is that we can't get in.
It's because there's no handle. Who would ever make a door without a handle?
Do you consider a handle?
It's an imaginary handle. You have to use your mind.
Most sustainable architect in the world made a door.
It's a sustainable door handle. It's the one that's never been built.
Look at this. Most sustainable architect in the world. You are so clever. No handle here, not necessary, because the handle is over here.
It must have been an engineer thinking that
50% CO2 emission.
Brilliant.
Cut.
Thank you.
Only use handle on one side, if not necessary.
So a way of talking about concrete in a positive way.
Yeah.
Here, just next to the building,
The coal crane.
There is a coal crane track, an old one, from when this was an industrial area.
Yeah.
So the best thing about concrete is if you can directly reuse it.
Yeah.
So this is going to be a bridge, and so we are recycling this, you can say, all the concrete elements here. So that's a possibility.
That's a fantastic possibility.
Can be directly reused.
And you won actually that assignment 7 years ago.
7 years ago, we won that with a larger team.
And you actually didn't know you were going to build this house at that point?
No.
Life.
So, life connects.
Okay, guys. So we walk into this beautiful, wonderful building. So the first thing you did, trying to minimize concrete, what was that?
So, is that a helping finger?
That's my helping finger. That's
Pointing finger.
So the audience doesn't notice that I'm trying to help you.
Okay. So one thing we did to reduce the use of concrete in the building was to have no basement. So usually we dig the whole side out and we cast a lot of concrete.
Yeah.
Instead, we had no basement, no parking. We only have a small basement, which is for bicycles. So what we have to look at today is a different way to use concrete, or a new way that we are using concrete. So the fact that we are looking at concrete standing for 8% of the total CO2 emission, of course we need to find solutions.
Yeah.
So one way of finding solutions is to make some more sustainable concrete.
Yeah, but the first solution is minimize the use of concrete.
But we said that.
Yeah, but we're saying again.
We said that.
So now we're going to go in here and let's go up so we can look at the top floors that is actually being casted right now.
Yeah.
Dry casted? No.
In situ casted.
In situ casted.
Yeah.
Yeah, of course it's
that.
called that. So I don't know if you know it, Anders, but I used to do a lot of weightlifting. No, children's television. Nearly the same. Same, but different. Maybe we should start by looking at somebody else's way of building the old way.
Okay.
So this, because this actually, it's a nice view. So what we're looking at here,
Yes.
Are you not completely?
I don't.
You
I'm
don't
not
like heights?
I'm a little bit afraid of heights, or a lot actually. So
Okay.
I'm just gonna stay in here.
So what we're looking at here is a traditional dugout basement, and that could be in various depths. You know, 2-level, 3-level, whatever, right?
Yes. So what happens that is not so good is that you dig out a lot of dirt,
Yeah.
mud, whatever there's down there, and then you drive it away. So there's a lot of truck driving to get rid of what is there.
Yeah.
And then you hammer these walls, steel walls in,
Yeah.
which is also like really intensive in steel and CO2 emission to create those.
So you're already
So
there.
we're not even starting to use
exactly.
concrete.
You're not even beginning. We're already in
Yes,
in
yes.
minus.
And this is actually really incredible that when we calculate CO2 with life cycle assessment, these two things are not calculated in.
The steel walls.
The steel walls and the removal of all this dirt. Where the calculations start is actually when we then has to prepare the actual concrete. And in that there is of course all the arming of the steel in the concrete, which we can see here as well over there.
The arming meaning
all the steel
rods that you bind together,
Yes.
so the cement is having
Yes,
something
yes.
to clang on to, right?
Yes. So it can take both.
Okay, this is actually a bit unstable.
Yeah, it's not so good. Okay, but then you start to fill up the basement with concrete, and of course that is enormous amounts of volume you put in.
Yeah.
Both kind of the base, which needs to have a big deep anchor if you make a high building.
Yeah.
So you start to use a lot of concrete there. And that's of course a super big challenge. The site that you choose to build on has an impact on sustainability immediately. And where we're actually building now is on a beach.
Oh,
So
great.
this used to be the beach, right?
Yeah.
And then it's been claimed as an industrial area. And now after that, we are making it into a new kind of a office or residential area.
Yeah.
And so foundation is on basically on sand.
Can we see some of the foundation points down over here? So those squares down there, right?
Yeah.
Those are the fun, the anchoring on this building, right?
Exactly. I mean, now you can see where the containers are over there.
Yeah.
That is the footprint of the third building.
Ah, okay, yeah.
And the interesting part here is actually that the buildings that are 6 floors high, and this building that's 20 floors high, has nearly the same amount of pillars.
Okay.
Which is interesting in the looking at how many more square meters we're actually building. So even though we are up high with a light building compared to a heavy building.
Let's get some comparison. Now we saw a traditional way of doing it compared to this one. The amount of concrete for foundation at 3, what is that?
Yeah. What you can see here is that we've not digged out.
No.
So we have removed earth. But
like a couple of meters or
not even.
Okay.
1.5 meters, something like that. And then we put these vertical pillars in.
Yeah.
And then after that, casted a platform.
Yeah.
And you can see that there's not these steel walls around here.
No. So
we didn't have to go down, and it's a retaining wall for
you
the
don't
dirt.
need to.
You don't need to.
It doesn't expand because the weight of this building is much lower than the one over there.
Yeah.
Okay.
So that's a very, very, very big difference where we don't use that much concrete. What we've tried to do here as well is that the concrete company, Aalborg Portland, has developed a new type of concrete that reduces the amount of CO2 in the cement production.
Okay. And is that the same cement we have there as the one we have over here?
Yes. So we have then in the building, there's 2 ways of building with the concrete. In Denmark, typically we do elements. That's how you do it over there.
So that means that column on the side and the columns around
the slabs,
they're like built up of.
Yes.
Okay.
So it's all built on a factory.
Yeah.
And then they drive it from the factory and then assemble the building.
And why didn't you do that with this one? Because I guess you're gonna say now, we didn't do that.
No, I'm not going to say we didn't do that, but there's different reasons for that. Here we have this where we have the form of this kind of being able to move it up as kind of, you can almost see the scaffolding, right?
Yeah, you can see.
So it's almost like a rail, like a train where the whole top part can be moved up and follow the casting of the building all the time. So instead of craning elements in, you kind of start from the bottom and then you start to pour into the same form, and then you lift the form up and you pour more, and that's how you keep going.
But what is the advantage of that? Do they need more concrete to do that, or is it different?
In some situations, the in situ cast in place makes it easier for you to optimize for the use of that part of the building.
Okay.
Where an element's advantage is that you do the same element many times. That also means that it needs to be optimized for all purposes for the building instead of being customized for that situation where it's in.
Okay.
But for us here, we also have an aesthetic thing that in situ casted is a more beautiful form, beautiful shape where you don't have joints. Because if it's an element, you would start to have joints, and these seams is not very beautiful. So here we get kind of a full casted wall and shape at the same time.
But so let's talk about the concrete. Let's be concrete.
Let's be concrete. That's a good one.
As you say in English. I don't know actually if you say it. So that building, is that the correct height now, or is it 2 stories more?
That's 1 story.
1 story
more, and then there's the roof terrace where there's also a cafe on top.
Oh, it's gonna be so nice.
We're gonna sit
in a future episode. We're gonna do the cafe episode.
A cafe episode
where I do perfect latte for you. We've covered in early episodes how much the wood is a part of the bearing structures and the wooden floors.
Yeah.
What is the amount of concrete that you can leave out of a building like this?
In this case, it's around 85% of the material that we leave out and in weight. So if you would weigh this building, I believe it's around 13 or 15,000 tons, and it would have been over the double weight if this has been built in concrete. The fact that it's so much lighter is the volume of concrete that we're leaving out, because that is the difference.
So you have made a core of concrete.
There's some interesting things that you can do. We've tried in another project to use waste concrete and crush it and cast with that.
Yeah.
And we could see that we could save around 8% CO2 by crushing and then casting with the same amount of cement that we normally do.
Okay.
So just on saving stone, sand, and all the things that you started by saying was a problem in harvesting virgin materials.
Yeah.
And in this case, we're then trying to create or use the new type of cement, and it's actually been an easy fix.
Yeah.
Because the concrete company has made this Future Sem product, which is reducing the CO2 emission in the fabrication of the cement.
Yeah.
So basically it just means that we're casting the way that we always do, but just with a different product that has a lower CO2 impact.
Okay.
And they are promising that you can save around 20 to 25% CO2. But that's really on, you can say, some of the toughest concrete where you really have a lot of cement.
Yeah.
And rarely we have that type of concrete in buildings. So for our building here, calculating what we are using, we are saving around 10% CO2 on the concrete.
Okay.
So it's not a lot, but it's a fantastic number. We have a lot of volume, and for sure it's making a difference.
And you can say one thing, in terms of the most CO2 emitted from the concrete production is in the energy of making it. And as we move to a way of energy that is more electrified, or we use hydrogen as a green fuel for fueling factories like that, that number will go down. There's an American company called, I think it's called Green Steel or something like that, where you have already been using other ways of melting the steel, and the CO2 reduction is enormous.
But it's a very interesting point. And the question is, with that statement, is it okay to use as much energy as you want, just as long as it's sustainable. I think that's an important question because, in my opinion, what we have to do now is to build and use material that uses as little energy as possible.
I know.
So, of course, it's good that we can start to have renewables, and there's other ways of creating this energy, but we must also accept that objects or materials that need so much energy is something that we should go around.
And I think it's an important thing is that we need both, right? We need to
absolutely.
we need to reduce the amount of material that is used from new. We need to recycle as much as you know as we covered. You know, we need to transition every aspect of how we do this.
Yeah.
And I think for this building, where you can see that you have used these. Are you getting tired?
Yeah.
Okay, great. So next time we do.
But it's such a beautiful view.
But it is actually very beautiful.
It's not gonna look like that, but it looks really awesome from here.
But it also looks like you're a very old man needing a nap.
Yeah.
In the middle of the episode.
Exactly.
Okay, so
For many years, architects has just loved this surface.
yeah,
I mean, it's just don't forget that the whole modernism, just everything was out of concrete. We loved that it was possible to build large buildings, complex structure and spans, and get this surface.
Yeah.
So it's also a mindset change
Yeah, it's
that
an
we
aesthetic.
are hogging the wood, and all of a sudden this is the bad guy surface that we don't like. But for the past 100 years or 50 years, this has been a symbol of high-end architecture.
yeah.
So it's also a mind shift change that all of a sudden something else is we conceive it differently.
Yeah, and then but what we found out when we had the conversation with the developers and the whole conversation about wood, and I'm really not exaggerating here, but you seriously want to hug these wooden beams. And I know it sounds stupid, but it's actually something that makes you connecting to a building in a new way. And I think the aesthetic and the feeling in buildings is going to change that way. So we're going to see this as a past and something that is necessary, but it's not something we want. And we're going to see this as our new symbol of a future that we need to change if we want to continue to be a human.
And it's because that knowledge, we're learning more. People learn more about what the impact of different types of materials are. So when they look at the concrete, they see something that's emitting CO2 or using energy.
Exactly.
When they look at the wood, they see something that symbolizes nature.
Yeah.
It brings down their pulse. Now we're looking at a black box. Okay, so you should ask me. So is there a future for concrete? The world's most sustainable architecture in the world.
Most sustainable architecture, yeah, that's nice. That's a good thing. You feel motivated by that one. Most sustainable architect in the world, Anders Lendager. Is there a future for concrete?
No. But there is a way of rethinking concrete, so there could be a meaningful way of using it. So we should use concrete the places where we don't have any other alternative. But the interesting part is actually we did an analysis of that, and we call it the concrete pyramid, and it's kind of like the food pyramid, right? So
Made out of concrete.
You shouldn't eat it. It's just
I get it.
You draw things. You should understand.
Yeah, yes. I get it.
So, in the top, what do we have in the top?
And we have the chalk.
In the top, we have the stuff we want the least of.
Yeah.
And in that is the concrete that we need for parts of the building that needs to be super stable. For instance, our ground floor here. So you need foundation in the ground. There's no alternative for that.
Yes.
And so when you go further down in the triangle, then there starts to become alternatives. Both new types of cement or concrete, but also the fact that you can disassemble the concrete. So we need to build buildings where you can take the parts of the building and disassemble them afterwards. So when a building is not in use, you have to take it down and use it for something else.
Yeah.
That's in the middle, and then you start to have a building that has almost no impact. When you direct reuse concrete, you use only 2 to 5% of the CO2 emissions than when you cast them.
Yeah.
In the bottom of our triangle pyramid,
I am there. I'm at the bottom of it.
you have all the pieces, staircases, all the pieces that are part of a building that are light and can be moved on, inner walls, all of that stuff.
Yeah.
That's also something that can be designed for disassemble and reused again and again.
Yeah, so it's an overall material pyramid, right?
Yes.
So like
But the
concrete and aluminum and all that is in the top part, and you have...
No. It's only concrete. It's a concrete pyramid.
Okay. but
But I shouldn't have said food, because then you think
No, I was like,
so I could say the oat milk pyramid. Would that have greens in
Okay,
it?
so what you're saying is, in the bottom, everything made in the interior and that's made out of concrete should be able...
Maybe
He actually
Maybe
looked
you
at
should
it. He
take
actually
them-
looked at his watch like, okay, how much time do we have with this idiot?
do we have more?
Tell
maybe
the people about the bottom
a
of
power
the...
nap is maybe needed.
No, you had a power nap. Tell us about the bottom of...
I did.
Yeah, but I interrupted you so people didn't get it.
So the bottom part of the concrete pyramid, which is only concrete from top to bottom elements of the building, is staircases. It is parts of the building, inner walls
salt and
that
pepper
can be,
shakers.
if they're made of concrete, that can be moved and that are flexible, disassembled, that you can set up again and again.
Salt and pepper shakers.
For instance. So the fact and the matter here is, if you look at the whole concrete pyramid from top to bottom, the total saving, if you build like this, is extremely high.
Like this.
If we were to build this building, for instance, where the columns were direct recycled columns, the slabs were hollow decks that was direct recycled.
Yeah.
And only the parts where the foundation needed to be casted new with the best sustainable concrete we could.
Yeah.
Then the reduction would be
insane.
Really high.
Yeah.
And that's where I see a future for concrete, that it's more kind of leasing almost, or you're borrowing the materials to the building, and you can disassemble it and use it elsewhere. So you need to shop for walls that maybe is defined in size, and then we as architects has to design with those geometries instead of the other way around.
Like having a mentality of borrowing from resources and borrowing from nature instead of just using.